This is Scott from KIG. It's February 22nd, 2022. Today we're going to do a runoff video or videos of this 7.5 ton, 230 volt coolant, Cold Shot air-cooled chiller. We have all the covers for the unit, but for this test we're going to have the bottom covers off just to show you things clearly. And also this top cover here. For this particular configuration, having those covers off does not inhibit any of the airflow for the upward discharge on this air-cooled chiller. Before I actually turn the pump on, it's worth noting that if you are ever going to turn the chiller on and off, like say you don't want to run it on the weekend, it's good to do it right at the chiller selector switch here. Bring it to the off position here. We're going to ship it with the disconnect. Don't turn it off at the disconnect unless it's going to be for a long time, because even in this state right here, where the power is off here, the power is still live coming into the chiller, and also keeps the heater on this crankcase heater here. So when you first get this chiller, we want to make sure that this heater here, which is hot to the touch, want to make sure that's on for at least 12 hours before you actually run the chiller. So the first thing we're going to do is I'm just going to go ahead and turn the pump on for a bit here. When we do that, you'll see the control power up, go through a little test mode. And by the way, this is a matter of policy here. It's our model ACW C90 EOR, serial number M042911-1, pump 2 horsepower. It's got a 2 horsepower process pump. That 90, by the way, that stands for 90,000 BTUs per hour nominal, which equates to 7.5 tons of cooling. When you do first get the unit, you saw me just turn the pump on there. To check phase rotation, it's good to have a second set of eyes or hands, and you just bump that pump switch, and with a flashlight here we want to make sure that that pump is rotating clockwise while looking from behind right through that little vent window. If it isn't, and of course you should have a licensed electrician, if it isn't, then you should change any 2 of the 3 incoming power legs. Related to power, it's 3-phase 230 volt. It can handle as low as 208, as high as 240. Again, we're going to ship it with this disconnect here. We may remove the disconnect and put it in a box. But anyway, the main power connection comes right up here. You can see these lines coming from the disconnect, and comes right to that main primary contactor that you see right here. L1, L2, L3, and then your ground right here. So if you get the phase wrong initial startup, you want to swap any 2 of those. Again, this is geared towards the electrician who will perform your initial connections. So we're running the pump a little bit right now. I'm just going to go ahead and start chilling and talk about a few other things while it happens. For our test, and we've tested it extensively, we simply fill up the tank, create a little loop, let it kind of heat itself up. It heats itself up eventually just through the friction of flow and the pump itself. Down here, this shows you SP, that's our set point. The red shows you what the current value is. The only thing you really need to know how to do is change your set point, is to press the right button here, little arrow, press that once, it changes set point, and we're going to bring this down to 48 degrees today. Oops, sorry. Let's go a little fast there. You bring it to your desired set point, and then press set again. Okay? So that you can see that's our new set point right there. Then we're going to change it to our cooling cycle, not just pump only. When you're on cooling cycle, the pump will continue to run full time. So when you do that, it's going to go through that little reset of the controller again. But this that set point should be embedded in memory. Let's see how that come up. Yep. And so you just heard the compressor turn on. Now this unit, not all of them have it. This has a little remote panel that you can bring indoors. We just kind of have it hanging off the side here. That will ship in a box. And with that, you can do what you can leave the chiller just on the cooling cycle there, and you can just perform your off-on if you want to run this cable in the building. The cable it currently comes with right now is fairly short, and let's see how many conductors that is. I think it's 5. But that remote cable comes up here into the controller area, and that comes right to this terminal block right here. And there's 6 connections. It should be pretty obvious. The orange to orange is a little bit questionable. We'll probably mark that. But the black to black, yellow to yellow, brown to brown. We'll disconnect that and make sure it's clearly labeled. So right now in the shop here, we have the low ambient thermostat. It's going to be set at about 70 degrees. So that means anything below 70, the low ambient control or fan speed control is going to be run by the P66 fan speed controller. Above 70, it will click and the fan will run full speed. Depending on your ambient conditions, we may end up adjusting this, and we'll help you over the phone. But this is an outdoor rated unit with that low ambient feature. You can hear it running right now. We have a 2 horsepower pump here, insulated. This is your out from process. This is your in. This is our test loop right here. This here is your bypass. So the pump draws from our reservoir tank, discharges up and out to your process here. We're going to ship this bypass opened about halfway. Ultimately, you may need to adjust that in the field. An example of adjusting that more open, if you will, is if our flow switch, which is here, which is the return coming back to the chiller, is not satisfied. An example of that would be as if your process has solenoid valves on the inlet to your machines, and they're all closed. And if you don't have enough flow coming back to the chiller, then we'll want to open up this bypass a little bit more so that your flow switch right here is satisfied. This here is important. This is a Y strainer. You take this out, check the mesh. It's more or less a filter. That's something you want to do regularly. And we have the heat exchanger, the evaporator for this chiller. The way we do it, it's actually submerged inside this stainless steel glycol tank. And we do have the cover. In addition to having all the covers for the side, we have the cover for the top of the tank also, which I think we just put right over here. Built into the controls is a differential, which is on every chiller. So if we set this at 48, it's going to probably stop at 46 -2, and it's probably going to drift a little bit, and then the compressor is going to turn back on at about 52. So a bandwidth, if you will, or a differential of a little over 4 degrees, and that's typical. You need that You need that to prevent short cycling of your chiller. You can see right now we're approaching 56 degrees. So again, if you use the remote start stop, you can just leave it on cooling cycle all the time and just turn it off at the remote start stop, and then your heater band here on the compressor will always be on. And that's important to keep the refrigerant down there warm when the compressor is not running. If there's a high pressure issue, you have this resettable high pressure switch. Doesn't happen too often. That would happen in a case where either the fan stopped working on a hot day due to a fan motor failure, or if the condenser coils were so clogged, not creating enough airflow of the condenser, that it would create high refrigerant pressure for the R410A. There's your drain on your tank. Oh, this is kind of nice on these. This is a little fill port. Just open that up. It's 2 inches, and you can fill your glycol in there. So obviously you don't want to run the pump at all unless you have your glycol or water in there. We have a nice sight glass here on the tank. So we're getting close. I think this is just going to be a one video deal today. So in your initial startup, you're going to fill the tank, turn the pump on for a little bit, pumping fluid out to your lines or jackets or your own heat exchangers, whatever you're cooling, and keep doing that until until the tank is full and stays full. I think you're going to hear something go off in a second. We'll probably get a little bit more drifting. My 2-degree estimate was correct, so we're at 46. Now we're at 45.9. I go a little bit farther.